Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. Let's continue our discussion with Decaf grammar. So the grammar that you are looking at the screen now is Decaf grammar, and as we have mentioned previously, the arithmetic operations that this grammar is capable of handling includes addition, subtraction, multiplication and division. It is also capable of handling assignment using move atom and Boolean operator using test atom. For Boolean operation, the way that this grammar handles is by using this terminal compare. And if you notice, this terminal compare has an attribute of C. So this C attribute will be replaced with numbers from this comparison table. So for example, if you are doing a less than comparison operator, the C attribute will be replaced with number 2. Okay, without further ado, I'm going to start drawing the attributed derivation tree. For input, A equals to, in parentheses, B, not A equals to, A equals, in parentheses, B equals to 3 plus C. Okay. If the first thing that we need to do is to look at our input, and if we see that there is a Boolean operator inside our input, it is important for us to start with Boolean expression. If not, we will start with expression. Since this input has Boolean operator, I'm going to start our tree with Boolean expression can be derived to expression, compare, expression, and test. We are currently drawing the tree, and our current input is A. Now, if you notice in Decaf grammar, there are two rules derived from expression, which is rule number 2 and rule number 3. How do we know which rule to apply? The way to do this is to look at our current input and look at the next input, a single step ahead. So our next input, if the next input is assignment operator, we need to apply rule number 2. However, if the next input is not an assignment operator, we need to apply rule number 3. So in our current situation, the next input is an assignment. It's not an assignment operator. It is a Boolean operator. Therefore, we need to apply the third rule. Expression can be derived to R value. There is only one rule derived from R value, which is rule number 5. So I'm going to directly apply them in the tree. R value derived to term list. One rule derived from term, which is rule number 9. So term can be derived to factor and list. As for factor, there are 5 rules derived from factor, and to know which rule to apply, look at our current input. Our current input is A, and A is an identifier. Therefore, I'm going to apply rule number 17. Factor is derived to identifier, and I'm going to directly assign the attribute of this identifier as A. So we are done with the first input. The second one is a Boolean operator, and just like we mentioned previously, Boolean operator can only be placed as an attribute of compare. Therefore, this list will be assigned to epsilon, applying rule number 12, and this list will be assigned to epsilon 2, applying rule number 8. Now we are at compare. In order for us to know which attribute of C should be applied, let's look at the comparison table. Our current input is the equal operator, Boolean operator, and the comparison code is 1. Therefore, I will assign the value of 1 next to compare. So we are done with the second input. The next input is left parenthesis. Again, we need to decide under expression which rule to apply. So let's look at the input next to left parenthesis. And B is not an assignment operator, therefore this is another implementation of rule number 3. Assign to R value, and then R value assigned to term list, term assigned to factor list, and then factor. We have 5 rules derived from factor, but since our current input is left parenthesis, we will apply rule number 13. So it's going to be left parenthesis, expression, and right parenthesis. Therefore, we are done with left parenthesis inside the tree. Our current input now is B. Okay. Again, we repeat, there are 2 rules derived from expression. In order for us to know which rule to choose, rule number 2 or rule number 3, let's look at the input next to B. So input next to B is an assignment operator. Since the next input is an assignment operator, here we need to apply rule number 2. Expression can be derived to assign expression. There is only one rule derived for assign expression, which is rule number 4, identifier. And this identifier has the attribute of B, assignment operator, expression, and move atom. Okay, so we are done with this. Moving on, the next input is equal sign. But if you notice, equal sign is also already added inside the tree. So this is done. Moving on, our current input now is 3, and we need to draw 3 under expression. Whoops. Okay. Okay. So next to 3, the input next to 3 is right parenthesis. Therefore, here in this expression, we will be applying R value. R value, and then R value is derived to term list, term is derived to factor list, and our current input is 3. 3 is a number, therefore I will apply rule number 16. Factor can be derived to number, and the attribute is 3. Okay, so we are done with this input, and the next input is right parenthesis. If you notice, right parenthesis is already here inside the tree. Therefore, the T list and E list here will be assigned to epsilon, because we do not want an attributed derivation tree that has non-terminals as its leaves. All the leaves must be terminals. Okay. The next input now, so this is done. The next input now is plus sign, and we are currently looking at this branch, T list. Okay, now let's look at our grammar and see whether T list can be derived to plus. T list currently cannot be derived to plus, since T list can only be derived to multiplication and division, rule number 10 and rule number 11. Therefore, what we're going to do is derive them to epsilon, implementing rule number 12. Then we go up another level, and we are looking at E list. Can E list be derived to do an addition operation? Yes, if we apply rule number 6. Therefore, let's apply rule number 6 here. So a list can be derived to plus, term, add, and a list. Okay, so we are done with this. And now we need the final input is C, and we are looking at drawing it under term. There is only one rule derived from term, which is factor delist. Okay, 5 rules derived from factor, but since C is an identifier, factor to identifier with an attribute of C. As for the rest of the remaining non-terminals, we're going to assign them to epsilon. Okay, we are done with the first part of the tree, which is just drawing the tree. Next, we will pass the attributes. Let's continue with the next part in our attributed derivation tree exercise, which is to pass all the attributes and complete this tree. So I'm going to start from the leftmost branch, and this is the way that we derive attributes from left to right and from bottom to top. So I'm going to start with this branch, factor to ident. And the way that I'm going to do this is I'm going to highlight the rule that the rule that we used to derive or to draw the tree, and I will highlight it on the grammar. Therefore, you are going to see how do we pass the attributes. Okay, so for this particular branch, we use this grammar, and the attribute of ident is P, and the attribute of factor is also P, which means they should have the same attribute. So I'm going to directly pass the attribute of A up to factor. And then I am looking at the next branch, which is this term factor delist, which is now rule number 9. So I'm looking at this particular rule. Okay, so based on rule number 9, we already know the attribute of Q, which is A. And then we do not know the second attribute yet. However, since delist is derived to epsilon, and that rule is actually this rule, and the attribute computation rule says Q gets the value of P, and we already know the attribute of P is A. Therefore, the second attribute is also A. Okay, moving back to the branch of term factor delist of this rule, rule number 9. Now we already know the attribute of P. Therefore, we can also see that P is also the attribute of term. Therefore, I'm going to move A up. Next, we are looking at this branch, R value term list, and this branch is applying rule number 5. So from this rule, we see that we already know the attribute of Q. The attribute of Q is A. We also know that Q is the first attribute of list, and we do not know yet the second attribute. But since list is derived to epsilon, it is safe to assume that the second attribute is also A. And since we now know the value of P at rule number 5, P is also seen as the attribute of R value. So we move A up. Okay. Next, let's move another level up, and that level is this, or that branch is this. Expression can be derived to R value, which is an implementation of rule number 3. And it says that based on rule number 3, we know that we already know the attribute of P, and expression also has the attribute of P. Therefore, expression has the attribute of A. So we are done with the leftmost branch. So now I'm going to move to the next leftmost branch from the bottom, and that branch is this. Okay, so this is an implementation. A factor to num is implementation of the rule number. So I'm going to move. Okay, factor to num is an implementation of rule number 16, and we've passed the value similarly on the above branch. So I'm just going to go through very fast. So this is 3, and then term factor till is rule number 9. Therefore, we already know the attributes of Q. It is derived to epsilon. Therefore, the second attribute is also 3, and this also gets the value of 3. Now, for R value term is, this is an implementation of rule number 5. And this is rule number 5 is this. So based on this rule, we already know the attribute of Q, which is 3. Next, we also see Q as the second attribute of E-list. So this also gets the value of 3. E-list is derived to epsilon. Therefore, safe to assume the second attribute is also 3, which means the attribute next to R value, which is P, is also 3. Okay, next. Next is expression to R value. So expression to R value is an implementation of rule number 3. So this is rule number 3. And we already know the attribute of P, which is 3. P is also the attribute of expression. So this gets the value of 3. Now we reach at rule number 4. So if you look at rule number 4, from this rule, we already know the attribute of P, which is B. We also know the attribute of Q, which is 3. So here at the move atom, it says the attribute should be Q, comma, comma, P. Therefore, I'm going to write it down as 3, comma, comma, P. And assign expression, the attribute is P. 3, comma, comma, B, not P. Our assigned expression, the attribute is P, and our P is B. So I write B here. And then expression to assign expression is an implementation of rule number 2. Rule number 2, here, rule number 2, expression to assign expression. And we already know the attribute of P, which is B. Therefore, the attribute of expression is similarly B. Okay, so we were looking at this rule. Okay, next. We go to factor to expression. Factor to expression, both attributes P. Therefore, we just move the attribute of B up, And then term factor T-list at this branch is an implementation of rule number 9. So let me rub the rules that we used previously and highlight rule number 9. Term can be derived to factor T-list. So this is not the first time we made this rule and we derive the attributes for this rule. So I hope you are not lost. So we already know the attribute of Q, which is B. Q is also the first attribute of T-list, so I just write B. And then because T-list is derived to epsilon, the next attribute is also B, which means the attribute of term is also B. And then for R value term E-list is an implementation of rule number 5. So let me rub rule number 9 first and highlight rule number 5. So from this rule, we know already the attribute of Q. The attribute of Q here is B. Therefore, we also see that Q is the first attribute of E-list. So I'm going to write B, and we do not know the second attribute yet. Since E-list is not derived to epsilon, you cannot write B as the second attribute. We need to derive it from the branches on the lower part of the tree. So here, all of these rules we have referred previously. So I'm not going to refer to the rule, but I'm going to explain what is happening. So this branch, factor to ident, both factor and ident has the same attribute. Therefore, since ident has the attribute of C, factor also has the attribute of C. And then term factor T-list. The first attribute of T-list is also C. Since T-list is derived to epsilon, the second attribute of C, which means the attribute of term here is also C. Okay, now we move back to this rule, E-list. E-list can be derived to plus, term, add, action, and E-list. This is an implementation of rule. So let's take a look at our Decaf grammar and let me rub this rule first. It is an implementation of rule number 6. Okay, so from rule number 6, we already know the attribute of P, which is B here. And we also know the attribute of R, which is C here. Add has the attributes of PRS, where S is alloc, which is a function to allocate a temporary space. Therefore, the values or the attribute of add will be B, C, and T1, since this is the first time we call for alloc. Okay, so S now has the value of T1. S is also the first attribute of E-list. So I'm just going to write T1 as the first attribute of E-list. And since E-list is derived to epsilon, the next attribute is also T1. Which means Q here has the value of T1 and Q is also the second attribute of E-list. Therefore, E-list here has the attribute of T1. Okay, you see that it has a different attribute than the first one. So if you just write BB, you're going to get the answer wrong because we have derived T1 from the lower branches of this tree. Now, moving on to this branch, R value can be derived to term E-list. this is an implementation of rule number 5. Okay, so this rule number 5. So from this rule, we already know the value of term or the attribute of term, which is B, and we know the attribute of P, which is T1, and the attribute of R value is also P. Therefore, we move T1 up. And as for the next branch, the above branch, expression can be derived to R value. This is an implementation of rule number 3. And since the attribute of R value is P and the attribute of expression is also P, both has the same attributes, which is T1. And now we are at the uppermost branch, the Boolean expression rule. So Boolean expression rule is, let me rub the previous rules. Okay, so the Boolean expression rule is this one over here. And what we want to do is we want to fill up the attributes of this test atom. So test atom has the attributes of P. So our P is the attribute of the first expression, which is A. So A, comma, Q. Q in this branch is T1. So T1, comma, 7 minus C. So our C is 1. So 7 minus 1 is 6. You directly write 6 here. And then L1. L1 is calling a a method called new label. So if this is your first time calling this method, you will get L1. If it's the second time, L2, just like alloc. And finally, do not forget the attribute of Boolean expression. Since this value here is L1, the attribute of Boolean expression is also L1. And this is our final attributed derivation tree, the one that is finished, where it has all the branches and all the attributes have been passed successfully.